Essentially, it uses it uses a transition probability matrix. You have a particular system like this one here on the left. You have some neurons with some logic and OR gate here, an AND gate and XOR gate. You have some external boundary conditions, and you want to, for example, compute to how much causal power does this system have? It's a trivial toy example. The advantage is you can explicitly set up the TPM, the transition probability matrix. In this case, it's deterministic. It could also be stochastic. And you can ask, is this system, does it exist for itself? Does it have some ability to influence just these neurons here? Because in principle, you have to do that for every possible, for these neurons, for these neurons, for these neurons, just for this neuron, just for this pair. You have to look at over all possible subsystems or supersystems, and you pick the one that maximizes this. So this is the postulate that translates the first axiom of existence. Consciousness exists from its own intrinsic perspective. You take this power approach, intrinsic causal power. You ask, how much intrinsic causal power does the system have upon itself? And then you can ask, well, for example, the composition axiom, you can ask, well, how many of subcomponents, if you have the full system, let's say those 3 neurons, how many of these subcomponents do they have intrinsic, if I just limit it to that pair or this pair or that pair or this single neuron, the first order mechanism, second order mechanism, third order mechanism, principally you have to do it for all, for the entire power set. You can ask, how much intrinsic causal power does this system have within that structure? And for each of these axioms, you translate it into a postulate. Integrated says, well, finally, I'm looking for the system that has maximum causal power. And exclusion says only that system exists that has maximal intrinsic power. Only that system exists for itself. It's a pretty radical claim, so think about it. So you look at the brain and you look at all in theory, in practice, you have to do all sorts of approximation. But in principle, you look at the brain and you ask, what is the substrate, the direct physical substrate for my current conscious experience, whatever it is. I'm looking at my laptop. And you ask that question. You ask the question of, well, the causal power of all various subsystems, these neurons and those neurons, and you add the neuron over here, and you do that for all possible combination of all possible neurons, which is, of course, an astronomical large number. And then you say, well, the system ultimately that is a substrate is a system that maximizes the total amount of integrated information. Only that system exists for itself. Any subset of that system has smaller integrated information, is less irreducible, and therefore doesn't exist for itself. It still exists as an external mechanism. It still has external causal power, right? Because it can clearly influence other neurons, but doesn't exist for itself. And only what exists for itself is true existence, because that's existence for itself. That's consciousness, right? When you're conscious, even in a sleep, when you're dreaming, you exist for yourself. 5 minutes later, when you're still asleep, but now you're in a so-called delta wave, when you're not conscious anymore, if I wake you up and ask you what went through your mind, nothing went through your mind. That's what you say. You're unconscious. You don't exist for yourself. So that is not existence for itself. And so there are these two different notions of existence. Existence for itself, that is a system that has the maximal integrated information over a particular physical substrate at a particular spatial, temporal scale and level of granularity. And so essentially you take a mechanism here, it's a very simple mechanism of 5 different gates. You unfold all of its causal power, it's a vast number, it's super exponential. You look at all possible combination of AB and BC and BD here. These capital and lowercase represent they are either on or off. You unfold all of its potential intrinsic causal power, and the claim is that this structure, this it's a physical structure, because ultimately we're talking about we're talking about operational things. You take and make a difference. You, for instance, fixate this neuron and then you excite the neuron over there, right? You observe. Ultimately, it's a physical operational thing. So any conscious experience is identical to the maximal irreducible intrinsic cause-effect structure. It's a maximum. Its quantity is characterized by phi. This is the integrated information. You can also think of it, to what extent is the system irreducible? The larger the phi, the more the system is irreducible to subcomponents. If phi is 0, the system doesn't exist, strictly speaking, and only its subcomponents will exist. Notice here, information in IIT is really the old, is sort of not Shannon information that's sent over a channel from A to B. It's sort of the Aristotelian notion, informare, to give form to. It's really much closer to Aristotelian thinking about form. IIT has this sort of this very explicit, I guess I should say, very explicit. It's rare to find that in science. Most scientists don't need that, but of course, when you're going to boundaries like at the superstrings or at the larger scale, or when you come to consciousness, you really have to think hard about your ontology, what exists and how do you know it exists. So once again, the system makes this claim that true or absolute existence, only when you're conscious do you really exist in an absolute sense. That's true existence. In deep sleep or anesthesia, you don't exist for yourself, so you simply don't exist. You still exist as an external body, right? Someone else can observe you and you still sees your body, but you don't exist for yourself. So that's absolute existence. This absolute existence is existence for itself. Relative existence is existence for others. So the body still, of course, has extrinsic cause-effect power. It still has mass, weight. Stuff is still happening there. The heart is beating, but that's all for an external observer. So this really constitutes, and there's a really interesting philosophical debate about this. This really constitutes the great divide of being. On the one hand, you have entities that are conscious, like you and I, like dogs and cats and maybe worms and mice, and we don't know how widespread it is in the tree of life. Those is absolute existence, existent for itself. On the other side are things like black holes and rocks and my computer that exist for others but don't exist for themselves. Yeah, an intrinsic entity is the only entity worth being. I don't want to be, I don't want to be a zombie when I have no conscious feelings, right? And certainly when I'm dead, I don't exist for myself anymore, which is, of course, why we're bothered about the notion of death. All right. So there are all sorts of corollaries, predictions, explanation, extrapolation. I don't have time to talk about it. There are a few things one has to think here about, careful, and any theory of consciousness will have to address these. The vast majority don't at all. You have to explain not only the existence of consciousness, but why any conscious experience feels the way it does. So space, even when you're looking at a complete blank canvas, empty, nothing there, you can say, well, it's just empty, and that's it. But this emptiness, in fact, hides a vast sort of complex structure, bubbling force, if you want, because there's neighborhood relationships, there's distance relationship, there's inclusion, there's exclusion. All of that is contained within the notion of an empty canvas. I can convey to you exactly what I mean by empty canvas because you also have experience of space. So you know exactly, but that's a high-level label. If you really try to think about it carefully, it's a very, very, very complicated structure that has to be explained. How does space feel? Whether it's seen space or heard space or felt space, all similar. Time flows famously, right? Flows, and it only flows in one direction, of course, right? And perceptually, well, that needs to be explained. Why objects feel very different, why colors feel, and why, pain feels a particular way it does, right? All of that has to be explained. So not just the existence of consciousness, but why do different things feel so differently? You have to explain a lot of facts. So, for instance, as I briefly mentioned, the cerebellum. In fact, here's a picture, an MRI scan of a woman who turned out, they discovered when she was 24, she was born without a cerebellum. So when us there's a cerebellum in her, it's just filled with cerebral spinal fluid, okay? Why? And we know this also from other people who lost parts of cerebellum due to surgery, falling tumors. People don't complain about loss of consciousness. Why not? There are these beautiful neurons here, cerebellar neurons, among the most beautiful and the most complex neurons in the brain anywhere. It has maps, it has representation, but it doesn't seem to be involved in consciousness. So IIT is something to say to that. IIT also came up with this new, I'll just be again very brief here, I'm almost done, biomarkers for consciousness. This is really important because there are tens of thousands of people, patients, who following either acute patients or chronic patients, they can be in the state for many years, following a stroke or a heart attack, following with ischemia or traumatic brain injury, car accident, blunt object trauma, etc., unconscious. They are clearly alive, although very often, usually, in fact, they are on life support. Sometimes they may open their eyes for several hours, then they close them again, or they might groan or move about. But we have no evidence at the bedside. The classical way, it's how it's still done today in 2022. You ask patients, Mrs. So-and-so, can you hear me? Can you move your eyes? Can you move your finger? Can you move your neck or anything? There's a significant fraction of people that are unable to do this. And so they're called either, when they can do it occasionally, they are called minimal conscious state. When they can't do it at all, they're called vegetative state. If this lasts more than half a year or a year, it's called PVS, persistent vegetative state. In some cases, like Terry Scheiber, she was in this state for more than 14 years. The other thing is very often in acute care, after 7 or 10 days, if the patient is in this state, very often in consultation with the family, critical care is discontinued and they withdraw life-supporting care, in particular ventilator support, and the patient dies in the absence of precise diagnostic and prognostic indicator of the presence of consciousness. So right now, there's simply no tool that tells me this patient right now is conscious. So out of IIT came this tool. It was first published almost 20 years ago. Essentially, it's a high-density EEG device, and then you apply a magnetic pulse. So it's like you essentially ring the cortical bell. It's like, you hit a bell with a hammer, and you're listening for the resonances. In this case, you hit it with a magnetic pulse that induces, via Maxwell's law, induces current in the cortex, and you're listening to its echoes, and you essentially compress it. And it turned out there's a magic number, 0.31. If the complexity of this resultant brainwave is below a threshold, then in every case where it's been tried now in several hundreds of volunteers and the patient or the subject is either unconscious, either because they're in deep sleep, or because they're anesthetized or doing different types of anesthetics, or they're in coma, or they're if it's above this number, they're awake, normal, or they're in a REM sleep, or they're on a ketamine where they don't respond, but they're clearly conscious because they're in a dissociative state. And so this is now being tested in clinical care.